Hello everyone and welcome back to Let's Unbound. Yes, we are back and today we are diving into FRQ2 from the AP Calculus AB 2025 exam. This is also a calculator based question, so make sure you have your calculator ready. As always, we will walk you through a clear step-by-step explanation so you can really understand the problem and how to solve it like you would do it on the real exam. Don't forget to watch till the end. We will be sharing some important tricks and key concepts that can really help boosting your score. Let's get started with FRQ2. Question number 2. The shaded region R is bounded by the graphs of the functions f and g, where f of x is x squared minus 2x and g of x is x plus sine pi x, as shown in the figure. You can see f of x is kind of parabola and g of x is kind of a curve. And we need to find the area of the region R, and then B is given. Region R is base of solid. For this solid, we need to find the volume for under certain conditions. And part C, we need to write an integral expression for the volume generated when the particular region is rotated about a horizontal line. And D part is, it can be shown that g dash of x is given. We need to find the value of x for which the line tangent to the graph is of f is parallel to the tangent of the graph sheet. Many informations. I'm going to break it down in a very simpler form for you. Be ready and be focused here. Yes. Find the area of R. Show the setup for your calculation. Here we go. Okay, how can I, this actually, we need to find area of this particular thing. It's not between area under the x-axis, like not a normal area, and we can clearly see that. So what case we are applying here? Area between two curves, right? So let's see here. And this is f of x and g of x is given. So always we will do top curve. So if you have these two curves, we will do integral, of course, from which interval, for the required interval. And then we have to do top minus bottom. In that way, we have to make the integral. So the region R is integral a to b. What is the top curve? G of x. We can clearly see this. And the bottom curve is f of x. So it's very important, g of x minus f of x dx. So what is my a and b? We can clearly see the intersection points of the curve here is 0, like x-axis. So 0, 0, 3, 3. So my a and b is a is 0, b is 3. So 0 to 3. What is my g of x? They have given over here. X plus sine pi x. So x plus sine pi x minus f of x. F of x is x squared minus 2x. What is minus f of x? Minus x squared plus 2x. Just multiply minus and then we will put minus x squared plus 2x. And close the bracket, use dx. You can simplify this before moving to calculator part, if possible. So here it is possible. We have one like term. X and 2x will be 3x. So 3x plus sine pi x minus x squared dx. That's it. Rest we can do it with Desmos. And this way also we can do. I will tell you this is a better way because we need to show and set up our calculation. Sometimes we can define g of x, f of x, everything in the calculator. That way also we'll do. But this is the best way to score the best score, right? Let's be the bestest. And here we go. Directly you can use the integrand. For example, integral, we have 0 to 3. This is what we have, right? I hope you might remember. 0 to 3 sine pi x minus x squared plus 3x. Somehow we have this expression, so let's give it. Okay, so 0 to 3 and use the bracket correctly in Desmos. So let me check what is my equation. I forget it. So 3x plus sine pi x, 3x plus sine pi. You can just write pi and use the bracket parenthesis for it. Here we go. And then minus x squared. And then put a dx. this evaluated the answer. So it's approximately to 3 decimal places. If you take, we can just interpret our final answer. Very simple. The one more way that I have told you is you define f of x. F of x is x square minus 2x. Okay, then you define g of x, which is x plus sine pi x. Sine, use the parenthesis inside that, pi and x. So can you see the exact graph we got? And then integral 0 to 3, of course. And then we don't want to give the simpler expression, simplest form of expression we did. Just give g of x minus f of x. And you need to give dx. Anyways, you will get the same. Okay. So to set up the, we have to show the calculation, right? So it's better to simplify over there, and then you can use the calculator, right? So here we go, and it's around 3 decimal places we need to do. So it's 5 point approximately 137, and area, right? So you can mention square units. If we have some unit mention, we can use that. I think just square units is enough. That's it. Part A is over. Very simple. Now, moving to part B. Region R is the base of the solid. For this solid, at each x, the cross-section perpendicular to the x-axis is rectangle with height x and base in region R. Find the volume of the solid. Show the setup for your calculation. Okay, we need of this here too. Let's understand with this diagram what they have given, what we need to do. Here we go. So we are going to make a solid 3D. For this solid, at each x, the cross section perpendicular to the x-axis is a rectangle. So this is being your base of a solid. At each x, for example, 0.001, it's an x-mins. We're going to make a cross section for this. And in this cross section, they have clearly mentioned what is height and what is your base. Okay, with this information, we need to find the volume of the solid. Okay, so we got height of the cross section that you're making. Height is x, base is the region R. Base is R means how can I get in an expression form, right? I need an expression form. We already did base area is g of x minus f of x. Okay, and height will be varying, depends on your x, the height will be vary and also the base will vary. Based on x, this value will also change. So volume is nothing but like summing up all the area. So if it's a coin, like I'm keeping a coin, all the areas you sum up, you will get a cylinder area. So that's the concept. So volume is sum of area. So I need to make area function. A of x is, we are making cross section in rectangle, right? So base into height. G of x minus f of x is your base. For that, respective height is x. That's it. So my volume is the base region have the limits from 0 to 3. So 0 to 3, a of x dx. That's it. So all I'm going to do is, we need to show and set up the calculation, right? So 0 to 3, you can put x into g of x minus f of x. So here one thing, we will tend to forget this x, whether using in calculator or copying out, right? So make sure you're including everything and double check it. Okay, so you can either simplify. Already we have the simplified version of g of x minus f of x. Okay, so you can use it to show the perfect setup. So v equal to integral 0 to 3 x into, we have this 3x plus sine pi x minus x square dx, right? So which is equal to integral 0 to 3 3x square plus x sine pi x. Don't put sine pi x square, okay? So x sine pi x minus x cube dx. And rest we can do with calculator now. So this is the way you have to show and set up the calculation. This resembles that you know the concept. You know how to solve this particular problem in a systematic way, right? And we are moving with calculator now. Here we go. Okay, so I'm going to do an easy thing. So I will just put x here, right? 0 to 3. And wait a moment. Okay, that doesn't work. So 3x square, when you multiply an x, 3x square, then here x sine pi x, and here x cubed. Right? We got the answer. Covered. So this is our volume. And I'm gonna share the whiteboard now. Here we go. This is the volume final answer. Yes, you can go with 3 decimal please. So volume is approximately 7.705, correct, cubic units. That's it. Very simple, right? And moving to part C. Write but do not evaluate an integral expression for the volume of the solid generated when the region R is rotated above the horizontal line y equal to -2. Previously we did volume, but the condition is height is perpendicular to x-axis and base is the base region itself. Here, yes, again we are rotating this and forming a solid. And when you're rotating, you need the about which line we are rotating, right? That line is not x-axis, not y-axis. It's horizontal line y equal to -2, right? So we can go with the washer method. So this is the formula for this, okay? A region R rotated about a horizontal line. So volume is not just summing up the area, okay? So it's pi integral, whichever we are working to A to B interval, and then radius of outer washer method. So if your washer is like this, we have to think radius of outer curve squared it minus radius of inner curve squared it. That is your integrand and dx. Okay, I'm just drawing this is just an example. This is not the final look. Based on our curve, it will be different. Right? So rotation about what? Y equal to -2. Right. So if what is my inside function, outside function? So R out will be g of x. So this is your g of x, and inside it is f of like we can take this as an example. Right. So this is radius of g of x from the line y equal to -2. Okay, we're gonna rotate it, and the solid will be formed. So this is how can I find the radius g of x minus of, so like the distance between them to the line. So it is g of x minus of -2, which is g of x plus 2, right? And r inside would be, inside radius is this function. So f of x minus of -2, which is f of x plus 2. That's it. We got this. And we can plug in volume formula that we have already defined. So 0 to 3 again, that is the intersection part, which is very clear. G of x plus 2, outer radius square minus inner radius square, f of x plus 2, f of x plus 2 whole square dx. Right? And this you can simplify, like at least show the expression. X plus sin by x plus 2 whole square minus f of x plus 2 is x square minus 2x is f of x and plus 2 the whole square. Don't forget the plus 2. That's the important thing here. And rest everything we can do with the calculator. Oh, actually, no calculator needed because they just ask you to write the expression, not to uh, evaluate. So this is the final part. And the last part, it can be shown that g prime of x is 1 plus pi cos pi x. Find the value of x from 0 to 1 at which the line tangent to the graph of f is parallel to the line tangent to the graph of g. Okay, so I got g prime and I need to find this. This is the condition. Whichever x satisfies this condition, I need to find it. Okay, so we can do this easily from the calculator. So tangent function means what? Tangent function of f is f prime of x. Tangent function of G is G prime of X. Parallel means they will be same. So the condition, the algebraic way of expressing this condition is f prime of X equal to G prime of X. So we need to solve this equation. And it's a calculator paper, so you can directly go to calculator and then equate them. Okay, you will sketch f prime, you will sketch g prime, and wherever the intersection, those are your x values, and check with the condition, your x should fall under this, right? So very basic thing. Once you've got this equation, then it's very simple. So moving to the calculator part. Okay, what is my f of x? F of x is x square minus 2x. Okay, then what is my g of x? You can directly do f prime and g prime also, but I'm doing this way. This will also work. 1 plus pi cos pi x. This is the parenthesis. Okay, we got it. Actually, we need f prime and g prime. So f prime of x, g prime of x have to be equal, means graphically they should intersect. So I'm just hiding these. If you remove this graph, f prime will go undefined. Okay, so that's very important. Just hide the graph. Okay, the purple one is g dash of x, and where they intersect from 0 to 1 alone, I'm going to look. Oh, actually g prime of x is this. I did a mistake. Right, g of x is not given. They directly give g prime of x. So this is not needed. And okay, here they should meet. So these two graphs should meet. And this is my answer. Okay. So this is g prime of x. If you give g prime, it won't show because g of x is not defined. So directly we have g prime 1 plus pi cos pi x and f prime. So they have to just, or you can just use h of x for g prime. Okay, so to avoid the confusion. So this is the intersection only valuable, like admissible point here. So 0.6752, and you can approximate it to 3 decimal places. That's simple. So we graphed and used it. Here we go. And your x is approximately 0.676. This is where tangent of graph f is parallel to tangent of graph g. And yes, that completes the entire problem 2, FRQ 2 from AP Calculus AB 2025. If this video really helped you out, so please subscribe and share it with your friends. Thank you for watching and learning with us. And one more thing, if you want to join a student community, yes, we have given a link in a description below. So you can click on that and join Let's Unbound Community WhatsApp group. And you will get more updates on AP journeys and many more. Right? Thank you for learning and watching. Keep learning and keep practicing.